Hi, I just wanted to cover a little bit about radiation versus radioactivity. So, it's kind of interesting to consider that radioactivity is a part of radiation, but there are so many other things in radiation as well. So, radiation covers all of the electromagnetic spectrum, which goes all the way from radio waves, which we really consider pretty harmless in general, all the way over to X-rays and gamma rays. Well, it includes also visible light. So we have the radio waves, we have infrared, which is the heat that is emitted off people essentially and other creatures. We have visible light, ultraviolet rays, which come mainly from the sun. And then we also have X-rays and gamma rays, which we especially consider to be radioactivity. UV falls under that as well. Okay, so here's another sort of idea to think about how it goes all the way from radio waves to gamma rays. And I know I'm sort of saying it backwards to the way it's looking on this table. And it's kind of interesting to think about this because it's tied to wavelength. So how big the wave is it a stretched out wave or is it a really tight wave? So that's a big thing. And how high the wave is and how quickly. So if it's a tight wavelength, you're going to have a lot of frequency of the moving wave. If it's a bigger, wider wavelength, the frequency will be less. Okay, electromagnetic spectrum covers all kinds of things. So this covers radiation from your radio waves, which we can kind of think about already, microwaves, TV remote control. That has some radio waves, microwaves that get emitted over to our TV. So there's different wavelengths that are at different times. I should have said it's kind of sitting between your infrared and your microwave type level for the wavelength there for your TV remote. Your night vision goggles, they're the ones that will pick up being able to see the infrared light, what is being emitted off an object for heat. Visible light, we're all familiar with that. Then we also have ultraviolet light, which comes from the sun, X-rays, and gamma rays. And these are the things that are radioactive. So, what are the uses for some of these things? Well, we can think of what happens here on Earth pretty easily. Radio waves are good for radio stations, tuning into your favorite tunes. They're also useful for seeing stars and gases because radio waves are emitted by them. Microwaves, well, we generally think of a microwave for cooking food, but it's also useful to learn about the structure of nearby galaxies because there's microwaves emitted that way as well. Infrared, we think of those night vision goggles to see what is producing heat, and it's also useful in space in being able to map the dust between the stars. So all these things can be picked up from space and then we can analyze what's out in space. So visible light, we all can associate with that one pretty well. Humans think of this as light, fireflies, light bulbs, stars. These all emit visible light, which you can tell. You can see the stars, right? So this objects all emit and absorb certain wavelengths. The color that we see from an object is the wavelengths that are being actually reflected. So there are certain wavelengths that are absorbed by an object. The reflected ones are the ones that we see as color. Ultraviolet light, we also think of that very easily about the sun. Creates sunburns and suntans. Well, we can also see some of the things that's going on in space by hot objects like the sun that emit ultraviolet rays. X-rays, yeah, we can associate that quite easily with medical aspects, but we can also look at hot gases that emit X-rays in the universe. So these are all things that we can look at and see what's going on in the universe just by analyzing all this electromagnetic radiation. Gamma rays. These gamma rays are used to image some things inside your body. And it's interesting to think about the biggest gamma ray generator of all is the universe. So gamma rays are everywhere. So we think of them as something we have to be careful of course, but they're all over the universe. Okay, radiation versus radioactivity. Well, we get to think about that a little bit. Radio waves and gamma rays aren't all that different. It depends on how much energy is within these waves. That's what makes the difference. So, electromagnetic radiation is produced through photons, which are a stream of massless particles. And these massless particles will travel at the speed of light. Each photon has certain amounts of energy, and these certain amounts of energy relate to whether it's going to be a nice big slow wavelength or a quick frequency of little small wavelengths. So we get thinking about that. We also sometimes think about the amplitude of how high the wave will be too. So energy levels will increase all the way from visible to ultraviolet to X-rays to gamma rays. So what happens is as the wavelength gets shorter, the frequency gets faster, and when the frequency is faster, there's more energy. If there's more energy, it's more harmful in general. It becomes more in the radioactive range. Okay, we can measure electromagnetic radiation. It's kind of a fancy formula, but it's extremely simple. It really is. So this funny looking, it sort of looks like an upside down V. That's called lambda. It's a Greek letter. And that's the wavelength. How big is that wave? Okay, that is equal to this funny swoopy V is a way of indicating velocity. How fast is the photon moving? And the funny swoopy F is usually kind of a curvy F, is frequency. Now, all these photons travel at the speed of light, which is approximately, you can make it shorter to be 3 times 10 to the 8 meters per second. So there's a direct relationship between wavelength and frequency. And you can calculate this out. Okay, the other thing to think about this is, why is it useful to have satellites in space? Well, there are certain things that, certain parts of the electromagnetic spectrum that reach all the way to planet Earth. But not all of it. Some of it doesn't get past the atmosphere. So by having satellites up in space, we can view more of what's going on in the whole electromagnetic spectrum of what's going on out in space. So we have different ways we look at it. Sometimes they do balloon experiments, which are about 35 kilometers above the surface, and they operate for a few months. So it works for a bit. Rocket flights can help, but rockets are only up for a certain length of time from Earth. For longer term observations, satellites orbiting planet Earth are very handy because a lot more things can be detected up there past the atmosphere. So here is a good rendering of just thinking about what all gets all the way down to planet Earth at the ground level and what gets stopped by about the atmosphere level. And as you can see, anything that's way up above the atmosphere gets to see a lot more of the electromagnetic spectrum. So this is just a summary of some of the things to think about when you consider radiation versus radioactivity. I thought it was just a nice little snippet to cover off today. See you next week. Thanks. Bye.